If you like this video, please hit the subscribe button at the bottom right of this video. In the early 20th century, the American West was a land of immense promise, and honestly some pretty formidable challenges. Central to this landscape was the mighty Colorado River, a powerful and unpredictable force of nature. For centuries it had carved the Grand Canyon, its waters surging with snowmelt in the spring and dwindling to a relative trickle in the dry summer months. For the farmers and growing communities in the arid Southwest, the river was a lifeline and a constant threat. Its spring floods could wipe out entire seasons of crops and destroy settlements, while the late summer droughts left the same fields parched and barren. A great and audacious idea began to take hold. What if this wild river could be tamed? The vision was to build a dam of unprecedented scale. Such a structure would serve multiple vital purposes. It would provide crucial flood control, protecting agricultural valleys in California and Arizona. It would also create a massive reservoir to store excess water and release it steadily for irrigation throughout the year, turning the desert into a verdant agricultural heartland. Finally, the immense pressure of the stored water could be harnessed to generate hydroelectric power, providing electricity for cities like Los Angeles and Las Vegas. The perfect location was the rugged, desolate Black Canyon on the border between Nevada and Arizona. The river flowed through a narrow gorge with sheer volcanic rock walls. These formations provided a strong and stable foundation, needed to withstand the pressure of a lake hundreds of feet deep. The site was remote, brutally hot, and almost entirely inaccessible, but its geological strengths were undeniable. Here the US government decided to embark on one of the greatest engineering feats in its history, a project that would test human ingenuity and endurance. The project was authorized in 1928 with the Boulder Canyon Project Act. It was a massive gamble, a federal investment on a scale never seen before. The plan was to build not just a dam but an entire infrastructure in the middle of nowhere. That included creating a new town for thousands of workers, building roads, laying railways to move colossal materials and machinery, and developing new techniques to handle unique challenges. The Hoover Dam, as it would be known, was more than a public works project. It was a bold declaration of American ambition and faith in mastering nature. Before a single bucket of concrete could be poured for the dam itself, the construction site had to be made workable. The first and most formidable obstacle was the Colorado River itself. A dam could not be built in the middle of a flowing river. The engineers devised a daring plan to temporarily move the river around the construction zone. This required carving 4 massive diversion tunnels, each 56 feet in diameter, directly through the solid rock of the canyon walls. 2 tunnels were bored through the Nevada side of the canyon, and 2 were bored through the Arizona side. The work of drilling and blasting these tunnels was perilous and grueling. Men known as high-scalers were lowered down the sheer canyon cliffs on ropes. They dangled hundreds of feet above the river, drilling holes into the rock with heavy jackhammers, and placing dynamite to blast away the canyon walls, clearing a path for the tunnels and preparing the foundation for the dam. These men worked in extreme conditions, facing the constant danger of falling rock, equipment failure, and the searing desert heat. They were the unsung pioneers of the project, their courage and skill making the subsequent stages of construction possible. Their job was to meticulously prepare the canyon walls, ensuring they were smooth and solid enough to bond with the concrete of the dam. Once the tunnels were completed, the river had to be coaxed into its new, temporary path. To achieve this, workers built 2 temporary cofferdams. These were smaller, preliminary dams constructed upstream and downstream of the main dam site. The upstream cofferdam blocked the river's natural channel and forced its entire flow into the newly bored diversion tunnels. With the cofferdams in place and the river roaring through the tunnels, the section of the riverbed where the Great Dam would stand was finally pumped dry, exposing the canyon floor for the first time in millennia and creating a massive protected construction pit. With the riverbed exposed, the final stage of site preparation began. An army of workers, using power shovels and trucks, descended into the pit to clear away millions of cubic yards of loose rock, sand, and silt. They had to dig down until they reached solid bedrock, a stable foundation upon which the dam could safely rest. This process involved removing over 1.5 million cubic yards of material, digging down as much as 135 feet below the riverbed in some places. Only when this foundation was deemed absolutely perfect by the project's exacting engineers could the next and most famous phase of the project commence: the pouring of the dam's concrete. Building a dam the size of Hoover presented a unique and unprecedented chemical problem. If the dam were poured as one single, continuous block of concrete, the chemical heat generated during the curing process would be immense. Engineers calculated that it would take over 125 years for such a massive structure to cool, and the stress from the uneven cooling would cause the dam to crack and crumble before it was even completed. The solution was as ingenious as it was complex. The dam was constructed not as a single monolith but as a series of interlocking vertical columns, much like a giant set of building blocks. This method allowed the smaller sections to cool and cure more quickly and evenly. The pouring of concrete began on June 6, 1933, and continued non-stop for 2 years. Bucket after massive bucket of concrete was transported from the mixing plant to the dam site via a sprawling network of overhead cables. Each bucket, weighing 18 tons, delivered 8 cubic yards of wet concrete, which was then carefully directed into the forms of the interlocking columns by teams of workers. The work was relentless, operating 24 hours a day, 7 days a week. The sound of machinery, the shouts of the foreman, and the constant movement of men and materials created a symphony of industrial might that echoed through the canyon day and night. To solve the cooling problem, engineers embedded a network of steel pipes over 582 miles in total throughout the concrete columns. Cold water drawn from the river itself and chilled by a massive refrigeration plant was continuously circulated through these pipes. This system acted like a giant radiator, drawing the chemical heat out of the curing concrete at a controlled rate. This innovative cooling process was critical to the dam's structural integrity, allowing the massive structure to be completed in a fraction of the time it would have otherwise taken. Once a block was fully cooled, the space between the columns was filled with grout, a type of thin cement, to fuse them into a single, solid, monolithic structure. The scale of the material used was staggering. The Hoover Dam required 3.25 million cubic yards of concrete, enough to pave a 2-lane highway from San Francisco to New York City. The construction of the Hoover Dam was a story of triumph, but it was also a story steeped in hardship and sacrifice. The project took place during the Great Depression, and for thousands of unemployed Americans, the promise of a steady paycheck in the Nevada desert was a powerful lure. Men flocked to the site from all corners of the country, desperate for work. However, the conditions they found were brutal. Boulder City, the official town for workers, wasn't completed until well into the project. In the early days, many workers and their families lived in makeshift camps called Ragtown along the river, enduring squalor, the extreme desert climate, and little shelter or sanitation. Black Canyon's environment was relentlessly hostile. Summer temperatures could soar to over 120 degrees F in the canyon. Inside the diversion tunnels, with gasoline-powered machinery, the air was thick with carbon monoxide and could reach 140 degrees F. Heat stroke was a constant, deadly danger. The official death toll is listed as 96 men. Many died from falling rocks, many died from falls from the canyon walls, many died from equipment-related mishaps. If you like this video, please hit the subscribe button at the bottom right of this video, but those figures exclude others who died from heat exhaustion, pneumonia, other illnesses linked to harsh conditions. Beyond heat, the work itself was incredibly dangerous. High scalers, suspended by ropes hundreds of feet up, faced fatal falls. Tunnel workers risked being crushed by rock falls. Tunnel workers risked being killed by premature dynamite explosions. A pervasive danger was inhaling silica dust from drilling, which led to silicosis, a debilitating, often fatal lung disease. 6 companies pushed the project at high speed, so safety measures were often secondary to deadlines, contributing to many accidents and fatalities. Despite all that, the workers showed remarkable resilience and pride. They were building something never built before, a structure that would stand as a symbol of human achievement for generations. This purpose, plus desperate need for jobs during the Depression, fueled their efforts. They endured heat, danger, and poor living conditions to finish the dam 2 years early. The Hoover Dam is more than concrete and steel. It is a monument to thousands of ordinary men whose sweat, toil, and lives were poured into its foundation. Completed in 1936, 2 years ahead of schedule, the Hoover Dam was an immediate and profound success. Its primary purpose, taming the Colorado River, was achieved. The catastrophic floods that had once plagued the Imperial Valley and Coachella Valley were now a thing of the past, replaced by a reliable and controlled flow of water. The massive reservoir created by the dam, Lake Mead, became the largest man-made lake in the United States, holding enough water to cover the entire state of Pennsylvania in a foot of water. This stored water guaranteed a steady supply for irrigation, transforming the arid lands of the Southwest into one of the most productive agricultural regions in the world and securing the water supply for millions of people. The 17 massive generators in the powerhouse began producing vast quantities of clean, low-cost hydroelectric power. This electricity was essential for the development of the Southwest, powering the growth of Las Vegas, Phoenix, and, most notably, Los Angeles. The availability of Hoover's power was a critical factor in the industrial boom in Southern California during World War II and the region's subsequent population explosion. The dam literally energized the American West, making possible a level of urban and industrial development that would have been unthinkable just a few decades earlier. Today, the Hoover Dam stands as an enduring icon of American engineering and determination. It attracts millions of tourists each year, who come to marvel at its sheer scale and graceful Art Deco design. It continues to be a vital component of the water management and power infrastructure for the entire Southwest, though its role is now complicated by decades of drought and increasing demand on the Colorado River's resources. The dam has become a focal point for modern discussions about water conservation, climate change, and the long-term sustainability of human settlement in arid regions. The legacy of the Hoover Dam is multifaceted. It is a masterpiece of design and construction, a symbol of a nation's ability to overcome immense obstacles during a time of economic crisis. It is a provider of life-giving water and power that enabled the growth of the modern American West. It is also a sobering reminder of the human cost of progress and the profound and sometimes problematic ways in which we alter the natural environment. More than just a wall of concrete, the Hoover Dam is a story cast in stone and steel. A story of ambition, sacrifice, ingenuity, and the enduring power of a grand vision to reshape a landscape and a nation. The Hoover Dam transformed not just a river but an entire region, proving that with enough determination, engineering skill, and human sacrifice, even the most ambitious dreams can be built to last. If you like this video, please hit the subscribe button at the bottom right of this video. Standing today as both monument and working infrastructure, the Hoover Dam remains a testament to what can be achieved when human ambition meets unwavering resolve. In an age of climate change and resource scarcity, the lessons of the Hoover Dam, both its triumphs and its costs, continue to inform how we approach the monumental challenges of our time. It stands not just as a marvel of engineering, but as a memorial to the vision, sacrifice, and determination that built the modern American West. The Hoover Dam, where human ambition carved permanence from stone, and where the dreams of a generation flow eternal through concrete and steel.